our focus is on performance tuning. So the way I've divided this concept is that first I would go over some core concepts which are in play when we are talking about performance related matters for BlueYonder WMS, how they apply, how the application server plays in it, how the database is utilized. Then I would go over how those concepts are available in the console, the Moca console that is available, how do those concepts apply there. Then I would go over some performance tuning concepts, which concepts we need to be very clear about in that regard. Then I would go over some tips, and then we would have a Q&A session after that. So first, about the core concepts. If you have been us for the last few episodes, every one of them starts with this slide, and that again speaks volume about elegance and consistency of the overall framework that applies in every discussion we are talking about. So when clients, which are users, which could be RF users, GUI users, web users, other systems, are interacting with BlueYonder WMS, it goes via Moca application server layer, and then all of the services are provided to the clients, the consumers, via this layer. We should never be trying to bypass this concept. This concept is right in the middle, and that is why when we are talking about any concepts like performance tuning, then we have to make sure that we keep this pristine view in mind, and with that try to see what needs to be adjusted or how it needs to be improved. So the way Moca provides access to the database is that the Moca registry has settings for both databases like Oracle and SQL Server, and that's how we provide the credentials and connection information to those databases. So again, SQL Server and Oracle are both supported. The way Moca views the database layer is that it assumes that you're connected to a single database, and then that single database will house all of the WMS tables in one schema for Oracle terms or one database in SQL Server terms. And that is this database, this registry then allows us to provide those kinds of details here. Connection pooling, I would go over a little bit later, but that is again a very fundamental concept that we need to understand fully. We have gone over that in the last few episodes as well, but that is something very fundamental, that the database is a resource from the point of view of Moca, and then which is a shared resource. So as your stress improves on the application server, like you have more users or more other actors getting added, the database would be considered a shared resource, and that is why this username password concept and everything like that is described here is very relevant. And all of the connection to the database is also abstracted from our consumers. Like when a particular application is connecting to Moca, where those username and password are application username and passwords, they are not database usernames and passwords. So database is a shared resource, and that is a very important thing that we need to understand, which also again to emphasize that we should never be trying to bypass Moca and going directly into the database via triggers or stored procedures, because that is where this concept gets violated and we get into trouble because of that. So and a very important concept is that BlueYonder supports both Oracle and SQL Server, and the way that magic happens is that all of the code should be written for Oracle, and then it is converted to SQL Server on the fly. So as a SQL statement is executed, it sees that the database is SQL Server, so it would convert the syntax to Oracle. So now this is again has a little bit of a history behind it, because Oracle was the first system that BlueYonder started with, and also as times have passed, if you stick to ANSI SQL and you stick to SQL 92 standard of joins, many of those reasons become less important, but you could still have a reason for using functions like NVL or whatnot. So it's a generally good practice to stick to Oracle syntax. If you are a SQL Server only shop, you could use those, but our general philosophy and methodology within SmartIS is that we always try to write code with Oracle syntax and let, first of all, write it with ANSI. If we have to go to something specific, then write to Oracle and let Moca convert it, so that we are covered in a situation if the database needs to be changed. That conversion I would not worry too much about from the performance point of view. It's extremely fast. There's not any performance related concerns around this automatic conversion that happens on the fly of SQL statements. So then what I was alluding to earlier was that connection pooling is something which is very fundamental that we have to understand when we are looking at the performance concepts. Like if you are coming from an Oracle world, then Oracle SID in $V session, or if you are looking at SQL Server, the SPID, that one session would be serving random requests over time. So there is no real value to, for example, tracing a particular SID unless it's a specific transaction that is stuck. Beyond that, those would be something which are really not applicable. A SID or a SQL Server SPID is a shared resource. If you start tracing on it, that would be tracing random transactions. So, another thing that we need to then understand is that the transaction is on the same DB session. So if one transaction is running, right, if you started something, did 10 updates and commit, as of the current versions of Moca, at least we know that that one transaction would be on one SPID or one SID. But beyond that, there is no guarantee of what database session is serving what use cases. So it's again very important to have that in mind, especially if you're coming from a DBA world and you're trying to diagnose something that going at just SID or SPID would not be of much help over a long term. So in that respect, we have to just clearly identify what is a Moca transaction. Again, the transaction is owned by Moca. Moca is going to be responsible for having a database session from a shared resource, then committing it and putting it back on the connection pool. So that is all a Moca transaction. So we have to understand what is a Moca transaction. So Moca transaction is a series of database calls which ends with a commit or rollback. Again, very important caveat that I'm talking about commit or rollback, which is Moca commit or rollback. If you put a commit or rollback within square brackets, which would be SQL commit or rollback, that is not ending a Moca transaction. Again, very important caveat that we have to understand that what ends a Moca transaction is the commit and rollback. And as we discussed in some of the earlier webinars, that Moca handles the transaction commit and rollback automatically when, for example, if a session starts from a client, if an RF use case starts, if the person moves inventory and presses enter, it would initiate a Moca command which would be running on the server. That whole thing would be committing a rollback automatically, and that Moca transaction would be implicitly created in that respect, which would be handling multiple SQLs within it. So again, a very important concept. The transaction concept is very elegantly represented in Moca. So we rarely see data corruption issues around this idea that, hey, my move inventory failed in the middle, so is my data corrupted because that one transaction executes a lot of SQL statements? So answer is no. Moca handles the database transactions very elegantly and how they are supposed to be done. So that is never an issue that we have to deal with. Of course, if we have a commit or rollback within our transaction in an exceptional scenario, that could create certain orphan records. But beyond that, when it is something straightforward and simple, multiple updates are all happening within a single transaction, and that transaction is handled quite elegantly. So it is possible to know the SID or SPID, SID for Oracle terms or SPID for SQL Server term, only for an active Moca transaction. So again, active Moca transaction, which would be a split second. So when you are moving inventory, that sub-second transaction where you hit enter and it executes some SQL statements, within that, yes, if you got a Moca SPID, that we know is tied to one Moca session, but beyond that, that SPID is really not useful from the point of view of a long-term view of the system. So that is one concept which we need to be very clear on when we're talking about performance issues, that what connection pooling is and what is the relationship with a database session ID and Moca sessions. Next concept which we have to be very clear on is the concept of automatic binding or auto binding. That's what we call in Moca. So first of all, we have to just understand what is a bind variable. So this concept exists in both Oracle, SQL Server. All modern databases have this concept that if you are looking at a table, you can put in a literal value. You can say select star from employee where employee ID is equal to a literal value like quote Saad code. You could do that. Or in Oracle, you can put colon A1. That is a typical way of representing bind variables in Oracle. SQL Server and JDBC would allow you to put like question marks for all of those. So the concept is quite generic. It is very crucial concept because that is what, when you are running a particular SQL statement, one of the most expensive parts of that execution for a database is actually parsing of the SQL statement, and especially if it has a lot of joins to figure out what is an appropriate way to run it. All of that is one of the most expensive and CPU bound operations. So this thing that we can have many SQL statements with bind variables so they look the same to the database is a very crucial concept. So just a little bit of a history lesson that, legacy issues rarely go away. So first versions, alpha versions of BlueYonder back in 90s did not have, they were just using, like many systems at that time, that literal values were being used in Moca command equivalents were at that time. And then, of course, as I indicated, bind variables are a very important concept. So once the load improved on that kind of a scenario, we realized that it's not working very well because of the stress on the database. So that is where the concept of auto binding were introduced. This is back in 90s, and the concept was quite straightforward, that it would simply look at literals in a SQL statement and replace them with a bind variable, and that's do all the magic behind it, because every SQL statement does go through Moca layer, so that was possible and feasible. And just like a little bit of more history lesson, that about almost a decade later, Oracle introduced the same concept, where is, say, parameterization of force. So again, the Moca was doing this a good decade before that, but that is where the concept of auto binding is, so that your SQL statement could still have literals, right? So you get the best of both worlds. The SQL statement is still going as literals, and Moca would replace those literals with bind variables on the fly. And that is, again, a very fundamental thing that we have to understand. So, so that what would happen is that if your SQL statement that is passed to Moca is as listed below, select star from odd where odd number is equal to blah, what would be passed to database. So what a DBA would see in the $V session or SQL cache area would be something like select star from odd where odd number equals to Q0. So that is very important. So now all of the, if you have this SQL statement was in the middle of pick release or any of this, so that is running thousands or hundreds of thousands of times, database sees the same statement every time. So that is again a very important concept that we need to understand. So it has a downside as well, right? So again, that is basically a legacy issue that is now with us, because the versions now at this time, Moca allows proper bind variables as well, but there is a lot of legacy code. So auto binding is with us, for now and for probably future as well. So what is the downside? So if you are familiar with the pickwork table, just imagine if your query, pickwork could have hundreds of thousands of records, right? If not more, millions of records in certain scenarios. If you did a query with pick status equals to P, there would be, even if you have a million records, there are only a few records, comparatively speaking, which would be in pending status, because majority of them would be in complete status. So, but if Oracle does not know, or SQL Server does not know this nuance of our data, so what would happen is that if the SQL converted from pickwork status to P to pickwork status of Q1, now the database does not know whether we should be using an index or not using an index, right? Because as we know, a general principle that if your SQL has a where clause which is going to resolve to, let's say, 80% of your table, then probably index is not a good idea. That's a general principle that we all know about, that index should be a selective index. So if your query is for P, then of course any database would properly choose a pick status index. But if the database does not know that, then a database has to guess that should I be using the index or should not be using an index, and it would see that the distribution is skewed. So pickwork of C has so many records and P does not. So it may choose to decide to choose a full table scan in that case. So both databases have a concept of bind peaking to kind of cover this kind of a possible scenario. So what that happens is that the first time database sees that SQL statement, it would see what is the value of, in this example, pick status at that time, and then make the query plan according to that. So if the first time this SQL was executed was with a P status, then database would just know that this kind of a query, I have to use an index because it was run first with P. But if over time, next time it is run with a C, then we would be still using an index when we did not want to use index, or vice versa. So that's again a very important concept, because we did not tell the database that it's a pick status of P versus C. Now we are going into the territory of certain defaulting or certain mechanisms happening according to that. Then there is also this other issue that we have, because this was introduced way back when, and it was introduced into a system, and Moca is really not going to know every type of SQL statement that bind variable resolution could affect adversely. So at that time, they had put in one fail-safe feature, which is still there today, which is that they would execute the SQL statement with bind variables. If it gives an error, then they execute the statement without bind variables, right? So that's kind of a fail-safe measure, so that user does not, if in that situation, if our bind replacement was wrong, it still executes correctly. So that creates a little bit of a issue for performance reasons, though. So just imagine this select statement that I have there, right? What Moca does is a very blind distribution. So it would end up replacing our decode statement in the order by also with bind variables, right? Because that's what it does. It just looks at the literals in your SQL statements and replaces them. In that case, SQL Server Moca would first try it with the bind variables, and it would fail because that's an invalid SQL statement. And then Moca would retry it, but at that time it would not have bind variables in it. The user in a development environment or test environment would not see a difference because they would get proper results. But we have a problem because in the database now, you are getting it flooded with the individual SQL statements. So we have actually seen a specific issue like that for one of our customers, where one of the SQL statements as part of pick release had this bug in it. And of course, the issue manifests only because what we see in that case, Oracle's SQL area was that it was getting flooded with SQL statements, and it was creating a huge stress on the database. So there are two nuances there, right? So first is that we could have an issue with where we wanted to pass in a literal, and the second would be something where if you have something in group by or order by, that by definition cannot have bind variables in it, but Moca will put bind variables in it. So that is where this very important hint comes in. So this is a Moca hint that you can put inside your SQL statement at any point /* no bind, right? What that is telling Moca's SQL parser, that has nothing to do with the database, that hey, from this point on, until I see /* bind within this SQL statement, don't do auto binding. So that's again a very important hint that we should make sure that we put in our statements where we want the literals to go as literals to the database. So that's again a very important hint, and first of all, it would give you whenever you are about to put a literal in your SQL statement, chances are that you want to put no bind hint. There would rarely be a situation that you are explicitly putting a literal in and then you don't want to bind no bind. So by default, if that is the situation, you want to put a no bind hint. So now, so this is how do these concepts of connection pooling, etc., are viewed at runtime? That's again a very important when we are maintaining the system, what is happening under the hood. So every session means that anything which is running at this time in Moca, running is very important. This is not connected users. So when you have a user connected, that is not a session. Session is something which is actually active and doing something at that time. So when a session is active, at that time, it has a database connection assigned to it, right? So database connection itself is a pool, as I indicated earlier, that when you log in, when you start preparatory, you would have, let's say, whatever your registry says, maybe 15, 20, 30 database connections already created. They are pooled resource. So as Moca sessions are created and they become active, they would get one of those database sessions from the pool, and that is how everything comes into play. And that's what you would see in the session. There would be a thread ID, and then if you go to the database connections tab in Moca console, that is where you would see that thread ID. So again, this only when a session is active will you see that thread ID on the Moca session. Each session in each database session within Moca is defined by this connection setting connection field that you would see on the Moca console. In the Moca console, you see a connection and thread. That connection is a very important field, especially if you are in a mode where you want to see what is happening on the database side. What ties this view to the Oracle or SQL Server's view is this field, which is the connection parameter. So which means that if you were to look at data in Oracle, you would see $sessions program field equal to that value. Database connection that you are seeing here, that becomes $sessions program. If you're in SQL Server, then sys processes program name would be that connection. So again, very important that there is this connection, which is very crucial in order to identify when things are happening. So that is very important. The second thing which is very important is that if you are in a database, which is database is clustered, so database is, Moca is clustered. So then there are multiple of these Moca sessions connecting to the same database. So in that case, this $session machine or sys processes host name also becomes important, because that is the host which is connected to it. So these two would then point uniquely to the database connections. If you are here, you know which Moca server you are on, and you know the connection, you can tie it to a Oracle connection at that time while the session is active. Again, that's very important to know that this is only while a session is active, but during that you can know. So if it's a locking situation or something like that, this is how you can figure out. You can start with a $, session of an active transaction. From there, you can figure out the program and machine and go to Moca console to see who is doing what. And similarly on reverse, you can do that. If there's a stuck process in Moca, you can go to the database session. So then there is this scenario of saying, who did that, right? Again, your use case could be starting from any side. So if the DBA indicates that this SID is stuck, who is doing what? That is the question at that time. You know, this is lock. Is somebody, what is the use case that is causing this lock? Again, the SID itself over the long term is insignificant. It's not important because the same SID would be a shared resource. It could be doing a pick release query and then a move inventory or something else later on. So that is not something we can go by. How it's supposed to then go down is that you would say, if you're in Oracle work, you would look at the program and machine, log into Moca console of that instance, find that program in the database. From there, you would get the thread. And for that thread, you would get in Moca console the user, device, warehouse, all of that contextual information would be available. So while the session was active, we have everything recorded. It's not like it's an enigma that we don't know what it is. SQL Server, the same idea. You would go to sys processes, get the host name, program name, and same troubleshooting mechanism would happen. Or the reverse is happening, that there's your application administrator is getting a call that, hey, this user is stuck on move inventory and it is not doing anything. The process is stuck. Of course, if process is stuck, transaction is active, you will be able to see it in Moca, and then you can do this thing in reverse, find the database session for it to see what is locked, or if they're locked behind somebody else, or if there's an orphan process. All of those can be then investigated using this mechanism. So then, of course, we do a lot of support activity, and this is definitely not fun to do it. So in our latest version of Moca client, we have added this functionality as part of the Moca client, so that the Moca console view, we have kind of calling the same underlying API in our Moca client, but it first of all goes across the cluster. So it would look all of the 7, 8 nodes of the cluster, get all of the information in this view, And then also it properly highlights, if you select a server ID, it would highlight what the database session is. So all of that would come in one view, and you can put in username and password as well to filter what is the actual user who is doing this transaction. So that is again something which if you have it, then it takes a lot of guesswork out of it. You simply go to the screen, press connect, you get the console across your cluster, Moca cluster, very easily. So now I would go over certain performance tuning concepts which are very important for our situation. First, very important concept is that in BlueYonder WMS, as the BlueYonder WMS views its schema, all tables and indexes fall in applications domain and not a DBA's domain. So we have seen a lot of situations where kind of there is this division to say that, okay, if an index is to be created, then DBA would create the index, and that change will be happening independently of the application's lifecycle. So that is a big no-no. Don't do that. It's not a right or wrong scenario. It is a methodology and philosophy scenario. The way BlueYonder WMS needs to be managed and it views its world is that the database is also in the domain of the application and not to any outside entity. So if you have to create an index, which we would always do, they are supposed to be delivered through proper rollouts. You know, there's alias dir dbddl indexes folder where you put the indexes and they properly go out. And of course, it's a team exercise that if somebody can certainly recommend an index and all of that discussion happens. But if an index is going to be added or removed or modified, that has to be an application decision and not a DBA decision. So DBA and database tuning advisors and all of those heuristic tools are good starting point, but not something where we just simply say, okay, this DBA tuning advisor recommended this, so I'm just going to accept it and I'm just going to create 4 indexes. That is a big no-no. We don't ever want to do that scenario. That is a good starting point. We start with that. We then analyze it. Maybe oftentimes you might have to, if there's a new index that needs to be created, probably there's an index that needs to be dropped, or maybe an index really needs to be modified. All of that needs to happen, and then an index properly gets deployed. So that's a very fundamental concept. Another very fundamental concept that we have to understand, especially as SQL Server is becoming more and more relevant, and also in case of cloud, that row level locking is something which WMS's code based almost assumes. That's coming from a bias of Oracle from way back when. So when the solution is, any solution is envisioned or was created, underlying philosophy of the solution kind of assumes that I would have row level locking. So, and things have improved quite a bit in SQL Server side. So by this time in 2020, we have a snapshot isolation level in SQL Server, and majority of the time SQL Server is also locking rows only, not pages. But this concept of lock escalation does exist in SQL Server. So lock escalation means that SQL Server decides at some point it might change row level locks to page level locks. That escalation is totally arbitrary from the point of view of application. Of course, it's making a decision based on whatever, but it has nothing to do with the use case in play. So you would be doing putaways in one area, and suddenly lock escalation could happen if, for example, if SQL Server decides that their threshold is met. So that can certainly happen, but that is there for a reason. If you don't have lock escalation, then SQL Server could go like that game that if you have lock escalation turned off, then you could have too many locks. That's again a fundamental difference between Oracle and SQL Server, where SQL Server keeps a table of locks versus Oracle does it slightly differently. So if we, as number of locks grow, that could have its own issues. So lock escalation is there for a reason, but if you're getting some acute issues, because what my symptom may be that it could create deadlocks in that kind of a situation. If that is happening, then there is this solution available, but you need to make sure that it is the right solution after discussing with the vendor, discussing with the specific scenario, making sure that there is no alternate way available. But SQL Server does allow you to disable this lock escalation on a table by table basis. So that is certainly a possibility, but we have to understand again, what is lock escalation? It would typically manifest as either long locks happening or sometimes deadlocks happening. Those are the typical symptoms that it creates. And then we have to understand like what is the background of it and why it's happening. Then there is certain use cases. Generally, we say that we never want to see commit or rollback within Mocha code. So that's generally not a good idea because it just is not very clean. But there are those exceptions that where we do have to put it. Where we have to shorten the database transaction, probably because of the SQL Server issue that I just mentioned, or maybe it is a long-running job like automatic load and close job that we are probably seen in various things, some cancel pick jobs. In some of those things which are long-running jobs, we might have to have a Mocha command which is going to do a commit or rollback in the middle. So here, if we are going to do that, first of all, we should try to make sure that that is absolutely last resort if we are going to do that. Then we should make sure that we use square bracket commit and rollback and not Mocha commit and rollback. That's again a very important caveat, because when we use commit or rollback without square brackets, that is kind of telling Mocha that my transaction has ended, and it would clear out all the session variables and stuff like that would happen at that time as well. So that is probably not something which you want. Like if you're making a, let's say, a job of looking at various shipments and maybe doing allocation or something like that of those shipments within one command, if that kind of a use case is being done, sure, I think it makes sense to do a commit or rollback after each one of those shipments. Then, but you probably want to use the square bracket commit and rollback, so you don't tell Mocha that my session has ended, because if as soon as you use the left side, that is going to be a little bit of a bigger side effect in that scenario. There is also what I mentioned earlier about no bind hint. So some of these histogram concepts are becoming less and less applicable now, because many times the database is able to figure those things out. But in either case, that's something which we need to understand, that if the SQL happened, there's a specific SQL in integrator that happens like that, where it looks for events in completed status or incomplete status, but it's the same API that gets called, which means that in those situations, if the bind variable is getting used, then the database would not know what it is, or if the bind variable is not even used, then Oracle's older versions would not know if there is a good index for it, because or if Oracle needs to know that P is a better P is more selective than C. That is information that Oracle needs to know. So for that, again, if you have auto statistics now in 2021, that some of these things go away. But if you have some legacy concerns, then there is this concept of Oracle was optionally would allow you to create a histogram on that column, so that the database would know that what is a good value and what is a bad value. So again, no bind and histograms would then go hand in hand. Just creating no bind is not enough for this reason, because even with a no bind, yes, Oracle knows that it's a SQL as P, but Oracle still needs to know that P is more selective and not C. So that is something where if you don't have auto stats turned on, then the histogram is something that you want to consider for Oracle. This is not even an option in SQL Server, so SQL Server is only automatic. If I have to see all of my support calls that we have dealt with for various customers over time, this is the elephant in the room, that we need to understand that when things are happening and the typical symptom is that it was running fine yesterday, but now it is not fine today. That's like a textbook symptom, that hey, everything was good yesterday, now it is not good, right? And in those cases, 90% of the time it is the plan stability issue. But that is where we want to make sure we don't get sidetracked. So that is where oftentimes I see that folks go completely sidetracked. So they would right away say, okay, I need to reorg the database. Totally useless activity. In 2021, if you are going to rebuild our indexes, you are giving Oracle and SQL Server engineers a lot of heartburn when you're doing it. It's absolutely meaningless activity to do reorging the database. Again, sometimes folks would say that, oh, I need to just right away purge. Now, purging or not purging is an independent discussion. We should be purging data. We don't want to keep it around forever and ever and ever. But if the symptom is it was fine yesterday and not fine today, then it is not a purging issue. It is basically an issue with plan stability. What happens is that imagine something like allocation, pick release, and any of those operations. They execute a lot of SQL statements within them, right? So move inventory alone would have several hundred statements in that sub-second sub-second use case. Allocation same way, pick release same way. So what databases today are trying to do is that they are constantly trying to see that, can I do it better? Can I do it better? And 99% of the time they are making a good choice, but they are looking at the whole database. So they might decide, okay, this one SQL, if I just run it a little bit differently, it would take less resources, and the execution time just goes from 0.01 seconds to 0.1 second. I'm just giving a hypothetical scenario. So it's just would decide, okay, I'm going to use this new plan for it. But that could have disastrous impact across the board, because that might be in the middle of an allocation query, and that is why it was being executed thousands of times, and now that 0.01 second to 0.1 second overhead has now broken everything. So that is something which happens quite frequently if your symptom is happening. This is plan stability. So all databases have a very nice solution for it, which is basically that you can pin the plan that you want. So Oracle, it is also called available, and in SQL it's called plan guide. In Oracle, it is pinning of a plan value from the database. Both of them have that option. But anytime you are having this issue, you need to right away focus to that discussion and make sure that we are not wasting that, because this is typically happening in a production environment. And that is where we don't want to be wasting time, because I would call it wasted time if you're looking at our purge strategy at that time, or if you're looking at reorging the database, though that's all wasted activity, when all of the time should be spent on looking at the SQL statement and then looking at what plan needs to be pinned for that, and that is where all of the effort should be spent. So that is basically, and we're seeing more and more of it, because this is a OLTP system. Our system is an online transaction processing system, where the typical SQLs want to use indexes. They are short transactions, short SQL statements, very limiting where clause. But as the databases are going towards very large databases, they are getting a more and more of a bias towards those kind of scenarios, and many of the default settings are around that. So that's why database would probably want to prefer full table scan these days quite a bit for even medium-sized tables, and then it has introduced full index scans, and some of those very sophisticated concepts have been introduced, and those basically are coming in the way of our typical OLTP kind of a system, where we like index lookups, we like nested loop joins. That's what we like. But many of these databases are coming with default settings, which are the other way around. So this plan stability is where we need to focus on all the time. So when we have this kind of issue coming up, how do we approach it, right? This is one of those things that is going to be happening quite frequently. So first, we should not be panicking in that situation. One thing I have learned is that however bad things are, one thing is guaranteed, that they can always become worse, right? That is one of the few guarantees that are available in a support protocol. So we must not panic. We must be making decisions in haste. We must not waste time on index reorg and stuff like that. And statistics can be an issue, but again, statistics would probably be an issue way back in the beginning of a project, but not if it was fine yesterday and today. But statistics gathering too aggressively can also be a problem. For example, let's say your pick work goes from 1 million records to 10,000 records after purge every day, right? What if you gathered statistics right after it was purged? So now you're telling the database wrong information, because it is going to go back to 1 million records by the end of the day. So that's why it's very fair that many organizations would lock the statistics when your database is fully loaded. For example, 1 million records, they would say actually statistics are locked. So that's a completely fair way to approach it. So again, in that scenario, when it was fine yesterday and not good today, chances are stats are probably not your issue. And then updating stats right at that time could make things worse. Again, we don't want to be making decisions in a panic situation at that time. And that is where it's very important that when things are calm, we need to make sure that every player in our organization fully understands these kind of core concepts, like what is the application footprint, how does BlueYonder look at the database, how does it BlueYonder want, how is the session, all of these things we are talking about, how to quickly find the top end queries, how to quickly find the old plan, how to quickly analyze a good plan. That is the discussion, that is the training, that is the exercises that should be happening when the things are good, so that we are not making rash decisions at the time when the things when things are not going well. So that is how we get into trouble, is that we would be in those meetings and then we would be taking totally wrong decisions. Certainly the DBA would say that, why don't you just change the SQL, not understanding that this is a packaged application. We cannot just change SQL statement, and then it also violates some of the change protocols. And the application versus database discussions would start happening, and all of those would go away if we just looked at the system when things are calm, understand all players involved should have the basic understanding of what the footprint is. They should be equipped to right away answer these questions: what are the top and worst queries, what was the old plan, how we want the good plan. All of that thing is happening right there, so then things would go much smoother in that situation. Then there is this issue that sometimes Moca provides a tracing capability, right? So let's say our allocation is slow, so it's a big wave. I allocate, it is taking longer than it should have been taking, or move inventory in certain situations is taking long. So of course, a very good piece of data that we would be able to get, if we can get that, is a SQL trace, a Moca trace in that situation would be very useful, right? So that is something that oftentimes people would get it. So like, even if it takes half an hour to get a trace of an allocation, let's get it, right? But then what happens is that once people have that trace, they see the size of that trace is 7 gig, and then that's where heart starts thinking that how am I going to make sense out of this trace? And the issue would be right there in that trace, that probably that one SQL statement running so frequently, every time is taking 0.01 seconds, but now it is running so frequently that it is taken maybe 2 minutes over the whole allocation cycle. So that is where that needle in the haystack could be very difficult to find, but Moca trace is certainly a very good starting point. And of course, we do support quite a bit, so we have seen this issue. That's why we have built this tool within Moca client, where it looks at a trace file and it actually views it more as in a macro view. So it would look that idea of a bind SQL statement, which is a very crucial concept, because that same statement is getting repeated over time. So it makes that as a key. So then what we can do is, since it is loaded into a database, now we can actually say, okay, select for distinct SQLs and now sum up the total elapsed. So right, each SQL, as I'm showing in this particular snapshot, the SQL statement was executed 2348 times, and its time was between 31 millisecond or 2 or 3 milliseconds. So if you're just highlighting bad SQLs, this would never show up. But then over the full run, that added up to this total elapsed time. And majority of the time, all we need to do is get that trace, load it into the database. This would not give you any problem in loading even a several gig database trace into the, it might take a few minutes, but that's pretty much it. It would load into the database, and then you can just view it and find the top query, and most likely it just needs some index tweaking or plan stability issues, and that would be it. So that's where we should be spending time, and not chasing other issues which are probably not going to be very relevant. So typical tips in this situation is when things are going bad, that we as I said, Moca tracing is certainly a very good starting point, regardless of even if it takes a long time. Don't get intimidated by the size of trace that it creates. We need to get that trace. That's very important. And then Oracle provides a very good tool, AWR. So anytime you're having performance issue, just right away ask DBA for an AWR report. That would give you a good view of the SQLs that are active and what are the worst performing SQLs. All of that data would be there. Or you can simply run a top end query. Both databases have simple queries which could tell you the worst performance queries at that time, because it could be happening that your symptom could be someplace else, but your problem query could be someplace else. That is a very important thing, that you might be seeing the symptom of inventory movement slow, but your issue might be that pick release, one of the SQL statements there was bad. So that this kind of a AWR report or top end query would be able to tell this information. And it is also very important to document what we found as well, because I have seen this, been involved here, that we try to tell them the reorging is not going to do anything, or purge is not going to do anything. But then there is this folk knowledge built in, that, oh, last time when it happened, at this time we did a purge, we did a reorg, we did this, that, another, and the problem went away. And now it is very hard to learn from it, right? So every time we should do very objective analysis post-mortem of it, that, okay, what was the actual solution, and we document just that solution, so that we don't have these folk tales building up, which are going to be problem for the next episode, because that is a guarantee. We are going to have these episodes over and over again. Databases are making a lot of decisions, and this is a ongoing trend. So, which means that we need to be prepared for the next episode of the same kind of scenario and be able to react to it quickly. So, some of the tips in this regard are that we, if we are tuning advisor is certainly a very good start. Both databases have good advisors, but letting it dictate the decision is a 100% of the time a bad choice. So we never want to say, my tuning advisor said this, I just want to accept that plan. Never ever want to do that. We want to see what it suggested, because chances are that what we want to do is probably accommodate that. If it's suggesting a new index, we probably want to take an existing index and probably add more columns to it, or maybe obsolete an index, put a new index. All of those things need to be happening, but just accepting that plan for BlueYonder WMS would always get into trouble. Again, learning when things are calm is very important. Documenting the outcomes is very important. The best friend for us is so that we know what we did last time. That is a very important detail that we have. Very objective tips, which have helped me quite a bit over time, is adding more indexes, more columns to the indexes is something very, very useful, right? Sometimes because we are talking about SQLs which are taking very short amount of time. So typical index lookup is that it looks up the index and then it goes look at the table, right? It could do a table access by row ID in Oracle, or do a cluster index lookup in SQL Server. You will see that in the plan. So that alone can be sometimes the problem child. So what we can do is we simply add more indexes of that SQL into the same index, and then that one step that we don't have to do is something which is often a lifesaver for these kind of situations. So adding more columns, which is you can call add directly to the index in Oracle, or in SQL Server has a sophisticated construct of include in the when creating an index. That alone is sometimes all you need. Removing bad indexes is as important as adding good indexes. So standard WMS has indexes on warehouse ID column, for example, and sometimes, and in a typical, even if you have 4 or 5 warehouses, you never want to go by index your queries by warehouse ID. So that is typically not a good index. So removing bad indexes is as important as adding good indexes. Always distribute index changes as a rollout. Let's not just create indexes in production. Even if we do it, then they should be followed up with a rollout. Having redundant indexes is also bad. That's why whenever we create an index, we want to make sure that if there was a similar index, we either drop it or add more columns to it. That is why letting tuning advisor decide is something which is never a good idea, because then you get redundant indexes. And always start with the top worst queries. That's every time there's a performance issue, we simply should start with the top n queries or AWR report tracing, and that's how we should go about approaching the problem. So this is basically what we covered today. I went over the basic concepts of Moca, how it views the database, how it is going to the connection pooling concept, transaction overview concept. Those are very important concepts, so we understand how database as a resource is utilized for BlueYonder. Auto binding is something very crucial to understand. If we are a DBA, then we need to understand that this is happening in on the Moca side. So if you're seeing a flooding of SQL statements, it's most likely a bug in some SQL statements. So that's very important. Otherwise, your SQL statements within the database should all be using proper bind variables all the time. And then you never have to use Oracle's parameterizing for force scenario. That is not really something you need, because auto binding should be happening in Moca. And then locking, we need to just understand what locking is and how it happens. So there's a few questions that were sent to us. I would go over those first. That first one is not related to our discussion at hand, but it was about dashboard feature and how easy it is to set up integration API and stuff like that. So dashboard is something which is there. I don't know which dashboard we are talking about. In 2020, basically the first screen that you see is kind of like a dashboard. Those are actually JavaScript, those are actually screens that are developed. Those are not something which you can just tweak. We certainly understand how those screens are supposed to be developed. We can make custom screens and whatnot, but those are not something which you can just say, put a row in a table and you can just tweak it. So if you have to extend it, then you have to fundamentally change that screen, which is certainly possible. That is not something which is not possible, but that is what we are talking about. In the previous version, there was a concept of actually a dashboard where it was a bunch of rows in the table. That concept has not been carried forward into the new version. So that is just something that we need to understand that. But if you need to, but there also I would say that many times if your idea is you just want to present something on a display someplace, then you can look at our website. We have a solution called JBoard that also provides like a airport kiosk kind of a situation. And that can actually navigate to a BlueYonder screen or have a Moca command behind it, and it would just keep displaying that in a kiosk kind of a scenario. So that is certainly available as well. Other question was that possible benefits of JDA 2019-20 over other WMS systems like Manhattan and HighJump. So I don't have experience with Manhattan. I have dealt with SQL Server, SAP and Oracle and JD Edwards. Every solution, every software has its own pluses and minuses. But where Moca excels all competitions is where it how it views as the change methodology of it, like some of the concepts which I described in the earlier presentations about how it views at the Moca component level, how the development framework is. That is certainly the most sophisticated, at least I have seen. Again, I cannot comment on Manhattan and HighJump, but it certainly is one of the most sophisticated things I have seen in the industry. So now we'll go to some of the questions that I have. One question is from Jawad, that if I set connection pool to a higher value, does it have any downside? So it really does not have any downside per se, as long as, again, this is all taking resources out of the database. And but you should do that like any activity. We don't want to just randomly make change. We want to make the change if Moca console would actually properly show that you have reached the maximum at some point. So if you have reached the maximum at some point, then it is certainly possible to improve it. But if you are having performance issues and you just want to increase it, that is not going to help any performance. And we have seen that even if you have hundreds of users, you would rarely ever need more than 20 or 30 database sessions. What can use up database sessions quickly, if you have some tasks, then certainly you can use it up. So in terms of increasing, it should not have any side effect of it, as long as the database doesn't mind and your operating system does not have any problem. Then I have a question from Imran, that inactive sessions in Oracle, and why doesn't Moca clean up after itself sometimes, and how to avoid it? So again, that goes hand in hand with the connection pooling. So first of all, Moca wants to keep a minimum set of sessions. It wants to keep it. So just because it became inactive, it doesn't want to remove it. But I think what is really being talked about is that if it was a defunct session, so for example, if a process completely crashed, which means Moca does not know about it and database still has it. So that does happen sometimes. So in that case, by definition, Moca would clean up after its sessions. Anytime we have this defunct situation, whether it is from Moca to Oracle or any other application, it is basically when Moca does not know about it. So something, if it was killed hard, a particular process, and or maybe Moca thinks it has cleaned it up. So those are the situations where it happens, and that's just part and parcel of the game. But by definition, Moca is trying to clean up its sessions. But this does happen when we do sometimes start-stop of Moca causes it, or sometimes maybe a transaction was too long and we killed that transaction in the database, and that kind of created that situation. So wherever it is happening is one of those scenarios that is happening, and that is why we have it. So by definition, though, it would be cleaning up. Then we have a question that sometimes we have a web service talking to a carrier and we are not getting response, and we have a timeout. On a happy path, we would get 20 megabyte trace, but when we have timeout, the trace size becomes gigs in size. So again, whenever we get these huge trace sizes, that does become a little bit of an intimidating thing. So that's one of the things that we are constantly looking at our Moca client to make sure that we can deal with those large traces. But this would be some things where you just, I always advise that, hey, don't get intimidated by these traces. Our Mocha database trace and those trace would be able to load these traces in. That should not be a problem. And then just have a coffee break and just look at that trace in that situation. Try to get as short of a trace as you want, and knowing some of the Linux tools to maybe trim the file, that can help. But again, we should be able to load those traces just fine into our database trace viewer and in our normal Mocha trace viewer as well. And then we can go from there.